Alright, 7.2, number 1. We're given that sine of theta is equal to 1 over 11. We're told that the terminal side is in quadrant 1, and we want to find the answers for the exact of each of the following 6 trig functions. So, this problem is telling us that based on the unit circle, okay, we're in quadrant 1, so we have maybe some right triangle here. This will be my right triangle. So let's say that this is theta. Sine is opposite over hypotenuse. So the opposite side, this measurement would be 1, and the hypotenuse is 11. So we're going to use Pythagorean Theorem to figure out the missing sides. And this is opposite over hypotenuse. We're going to use Pythagorean Theorem to figure out the missing side, and then we can find the other 6 trig functions. But from this, we can already get what I call the counterpart, which is CSC, cosecant CSC. We already know that if we flip that one, this will give us 11 over 1 or just 11. So that one I can get for free by knowing sine. Alright, but let's do it. So Pythagorean Theorem, I'm going to show the formula. A squared plus b squared equals c squared. To stick with capital. Alright, anytime we're looking for a leg, this is what's going to happen. We're going to remove, and it doesn't matter if you move a or b. We're going to remove a squared. So I'll have, let's say, b squared equals c squared minus a squared. Okay, because if I subtract a squared, I get this. And then I want to figure out what that side b is, so I take the square root of both sides, and then this is what I end up with. b equals the square root of c squared minus a squared. Okay, so this is the formula I'm going to stick with. If I'm looking for a leg, I'm going to use this. If I'm looking for the hypotenuse, I will use this formula. Alright, so we're going to use this formula. I'm looking for a leg, I'll plug in hypotenuse, and I'll plug in the other leg. So b is equal to the square root of 11 squared minus 1 squared. And that will give us 121 minus 1, which will give us the square root of 120. And we can reduce this. Because we want to continue working. We can reduce this. If we think about 4 times 30, because 4 times 3 is 12. And then I know we can break down 4 into 2 times 2. So we've got a pair of 2s. And then I could do 3 and 10, and then 2 and 5, so that won't reduce anymore. So we can reduce the square root of 120 to be 2 square roots of 30. And I think that's exactly what we want to simplify to. So that would be this side here, 2 square root of 30. Alright, and then based on that, we can do cosine. I'll go ahead and write them all down. Cosine of theta is equal to adjacent over hypotenuse. So that'll be 2 square root of 30 over 11. And then if we did tangent, that's adjacent, opposite over adjacent, actually opposite adjacent. So that would be, opposite would be 1 over 2 square root of 30. Alright, we would have to rationalize the denominator. So we would multiply by square root of 30, top and bottom, and that would give us square root of 30 over 60. So that's the form that we want. And then we already got CSC for free. if I flip cosine, that will give me secant. Secant would be 11 over 2 square root of 30. Also, we have to rationalize this. So multiply by square root of 30 on top and bottom, and that will give us 11 square root of 30. And then 2 times 30 would give us 60. And then with tangent and cotangent, if I do cotangent, I would just need to flip tangent. So from the original form, because if I flip this one, I'm going to have square root on the bottom, so I'm going to flip this one. And that would give us 2 square root of 30 over 1, which is just 2 square root of 30. So this is the form that I want here. All right, so let's enter these. So cosine, we got as 2 square root of 30. Over 11. Tangent, or square root of 30 over 60. Cotangent was just 2 square root of 30. Secant, which we get from cosine, was 11 square root of 30 over 60. Cosecant, you got for free, which is just 11. Alright, so we have several more parts we're going to look at. So it says given, we want to give the exact answer for this 6 trig function. So of pi over 2 minus theta. So this is, I'm going to go to the textbook, the cofunction identity. Pi over 2 minus x. Pi over 2 minus theta, same thing. So just notice, sine is equal to cosine when you do that. Pi over 2 minus theta, sine and cosine. And there, vice versa, cosine will give you sine. Tangent will give you cotangent, and vice versa, cotangent will give you tangent. Secant will give you cosecant, and cosecant will give you secant. So they just both kind of mirror each other. So we're going to continue. So if I do sine, this is going to give me cosine of theta. Oh, actually, they want the exact value. I'm sorry. Let me not do that. I forgot for just a second. So here's what we're actually looking at. Sine of pi over 2 minus theta is equal to cosine. It's equal to cosine of theta. Okay. From our previous problem, cosine of theta was equal to 2 square root 30 over 11. So that's what we're looking for exactly. So we're using the cofunction identity. So they give us this sine of pi over 2 minus theta, which by formula that equals cosine of theta. And from our previous work, cosine of theta, okay, was equal here. So all we're doing is kind of doing a plug-in and a mix and match. So this is the exact value. So we're going to be doing that for all of the trig functions as well. So we're going to be using the cofunction and then going back and finding our original values. So we want 2 square root of 30 over 11. And then cosine of this cofunction is equal to sine, and sine was 1 over 11. kind of got to plug in two at once, okay? So tangent is equal to cotangent, okay? So again, I'm just referring back to, and I'm just using the textbook, tangent of this measurement is equal to cotangent, okay? So cotangent, what we got was 2 square root of 30. So this measurement is equal to 2 square root of 30. And then cotangent of pi over 2 minus that is equal to tangent. And tangent we have square root of 30 over 60. Alright, and then secant and cosecant, they give each other's mirror. So secant was equal to cosecant, and cosecant we got 11. And then cosecant is equal to secant, and secant we get 11 square root of 30 over 60. Alright, and then we want to give the exact angle for the 6 functions of theta minus pi. So they have reversed the order. So there's two things you want to note when they reverse the order. So imagine this. Let's say I had some angle measurement. It doesn't matter. I'm just going to make up some numbers. Let's say I had 5 minus 4, for example. 5 minus 4 gives me 1. So I'm dealing with a positive angle. And then if I reverse these, if I had 4 minus 5, that would give me negative 1. So the difference of this is whatever I'm taking the value of inside of this parentheses, the angle, I'm trying to find the value of, is going to become negative. So we kind of need to see what the property does when it becomes negative. So there's two things we can look at. One is from the textbook. Okay, this next page, they give you what happens with sine and cosine. Okay, so sine, if it's positive, it's positive. If it's negative, it turns negative. With cosine, the positive of that is negative, and then the negative is positive. So it's going to change signs with cosine. With sine, it'll stay the same sign. So you got that one that you can look at, and then we also have the Trig cheat sheet. So with these even odd, so if I'm dealing with sine and the inside is negative, okay, so this is what I was trying to get you guys to see here. Once I make the angle negative, okay, so once you make the angle negative, that's pretty much what's happening. Then the outside will get a negative on the outside. The same happens with cosecant because they're counterparts. With cosine, if it's a negative on the inside, it's still a positive on the outside. Okay, and that's kind of what this property is showing you. Okay, so if it's a negative, that red sign negative is going to be a positive. It changes sign. Okay, and then with tangent, if it's negative, it comes negative. Same thing with cotangent. So sine, cosecant, tangent, cotangent, they will become negative. Cosine and secant will remain positive. Okay, so let's apply these properties now. Okay, so we're going to give the exact value. So with sine, okay, it's going to become negative. So it was sine was equal to cosine, so the same property holds, it's still equal to cosine. And cosine was 2 square root of 30 over 11. However, it's going to become negative. It's going to become negative 2. It's going to be the same thing here. Just changing to negative 2 square root of 30 over 11. And then with cosine, it will become negative, but it will stay positive on the outside. So it'll still be the value that we got for sine, which is 1 over 11. Alright, and then tangent and cotangent, they change signs, so it's the same that we just did above. we just want you to get that the sign changes. So for tangent, we will have a negative 2 square root of 30. And for cotangent, the value we got for tangent was square root of 30 over 60, and it will also be negative. And then last, secant and cosecant. So secant and cosecant also come, secant comes from cosine. It's going to stay the same. And then cosecant comes from sine, it will change to be negative. So this one will still be 11, and this one will be a negative 11 square root of 30. Over 60. So it's a lot going on there, but just focus on those relationships and you can get that part.